In this lesson, we will use models to discover multiples of a one-digit number in the range of 1 to 100. By now, students should understand the terms factor and multiple. Factors are the whole numbers that are multiplied to get a product. A multiple of a number is a product of a given whole number and any other whole number. As we look for multiples of a number, we will also look for patterns to help us recognize multiples of numbers. Let's begin with a problem where understanding multiples would be needed. The baseball park sells hot dogs in packs of 2. How many hot dogs could the baseball park sell? To solve this, we need to find multiples of 2 because the hot dogs are sold in packs of 2. A multiple of 2 is any product where one of the factors is 2. Since the hot dogs are sold in packs of 2, we are going to make groups of 2. Right now, how many groups of 2 do you see? No, this is not a trick question. There are 0 groups of 2. This represents the multiplication fact, 0 times 2, which equals 0. 0 is a multiple of 2. Now let's pretend I have 1 pack of hot dogs. I can represent this with one group of 2 counters. The counters represent the hot dogs. This shows 1 times 2, which is 2, so 2 is a multiple of 2. What if I had 2 packs of hot dogs? I will make 2 groups of 2 hot dogs, which is 2 times 2 and equals 4. So 4 is also a multiple of 2. Now let's model 3 packs of hot dogs. This would represent 3 times 2, which is 6, and 6 is also a multiple of 2. Continue this pattern with your child until they understand that a multiple of 2 is any number that can be built using groups of 2. Next, notice the equations created as you represent each multiple. Do you notice that the number of hot dogs in each group stays the same, but the number of groups change? Also important to notice is that this pattern could continue forever. There is an infinite amount of multiples for any given number. Now that we know some of the multiples of 2, let's write them in a list. It is important to help your child understand to separate each of the values with a comma. Referring back to our original problem, this list tells the reader that possible numbers of hot dogs that could be sold are 0, 2, 4, 6, 8, 10, 12, and we'll stop our list there and finish the list with 3 dots. Remember that multiples can go on forever? These dots tell the reader that there are more multiples and this list could be extended. As your child is exploring multiples, take time to look for patterns. If I use a hundreds chart to shade all the multiples of 2, I begin to notice some interesting patterns. Your child will probably first notice that it is every other square or every other column is shaded. Extend them beyond that to look at the digits of the numbers. What do you notice about the ones place? Notice with your child that the multiples of 2 only end with a 0, 2, 4, 6, or 8, and are all the even numbers. Also interesting to notice is that half of the numbers between 1 and 100 are multiples of 2. Now let's look at multiples of 5 using the same strategy that we did for multiples of 2. Start with 0 groups of 5. This represents 0 times 5, which is 0. So 0 is also a multiple of 5. Next I will model one group of 5, which is 1 times 5, which equals 5, so 5 is a multiple of 5. What about 2 groups of 5? 2 times 5 is 10, and 10 is a multiple of 5. Let's continue the pattern. Now, do you remember how to list the multiples? Write only the products or multiples and remember commas between each one and 3 dots at the end to signal that the list could continue. Next, let's use our hundreds chart and shade in all the multiples of 5 between 1 and 100. We are always looking for patterns. With multiples of 5, I notice that there is always a 0 or a 5 in the ones place. Noticing patterns will help your child to quickly learn to recognize multiples of a number. Let's look at a real-world problem. Monique and her dad do push-ups to prepare for a fitness challenge. They do push-ups in sets of 8. How many push-ups might they do if they complete multiple sets? In this problem, we are looking for multiples of 8 because they are doing 8 push-ups in each set. We already know that the first multiple of 8 is 0 because 0 sets of 8 is 0 times 8 or 0. However, in this context, we wouldn't include 0 as part of our answer because the problem signals that they completed multiple sets, and 0 is our starting place and not part of the answer set. So to represent one set of push-ups, I will lay out 8 counters. This is 1 times 8, or 8. To represent 2 sets, that is 2 groups of 8 counters, which represents 2 times 8, or 16. For 3 sets, I will lay out 3 groups of 8, which is 3 times 8, or 24. 4 sets of push-ups would be 4 groups of 8, or 4 times 8, which is 32. Wow, 32 push-ups is a lot of push-ups. Let's stop there. Now, to write our answer, the question asks, how many push-ups might they do if they complete multiple sets? Remember, we are not including 0 this time as part of our answer set. They could complete 8, 16, 24, 32, and remember the 3 dots at the end to signal that the list could go on. Repeat this activity with your child to find multiples of other one-digit numbers. Our goal today was to use models to discover multiples of a one-digit number in the range of 1 to 100. We did this by using counters in equal groups to create models of multiples and using hundreds chart to look for patterns. We met this objective by finding multiples of numbers and solving a real-world problem.